I listen to a lot of conversations about heat pumps and direct connections and hydronics, and a lot of people claiming to be gurus of hydronics, etc., etc. And I haven't. I'm not offering up too many challenges on this because I don't have an amazing amount of experience at doing calculations for hydronics on heat pumps. And historically, I've been doing calculations for boiler systems where we've got different delta T's, and it's fairly obvious when you need hydraulic separation and the benefits of reduced running temperatures, etc., etc. So one of the things I've been puzzling about is I'm seeing people talking about having mixed circuits on heat pumps without buffers. And my immediate reaction was, you can't do that. You're going to have, the minute you have different temperatures, you need to have different flow rates because you get mixing. And I've been quoting, I'm going to say my law, because I've never seen anyone else talk about it, where if you have an underfloor heating system, the temperature of the water arriving to that mixer has to be higher than the return temperature of that mixed system plus the delta T of your heat source. And if the temperature of that water arriving is greater than that, there's going to be a restriction in flow from the heat source. And that's going to create a variation in delta T at the heat source if you've got a matched system output. Sorry if you can't follow this, because it's really it's difficult enough trying to think of it and say it at the same time. So try and tag along with me, and I'll see if I can. They say if you can't explain something simply to a child, you don't understand it. So I guess I don't understand it, but come along with me on the journey. Right, so what I've done, I've been having a look at this. I'll show you this little conundrum I put for myself. So here's a system, and we've got a heat pump here, and we're going to feed a radiator system and an underfloor heating system. And if I understand the claims being made correctly, is that we can do this without a hydraulic separation. And they're talking of having delta T5 at the underfloor and delta T5 at the radiators and delta T5 at the heat pump at the same time as having different temperatures. Now, obviously we could have both systems at the same temperature and the same delta T because everything would be in balance. But once we claim a different temperature, we lose the balance. And I was trying to work out the impact of this. So I've got a little scenario here where I've taken 6 kilowatts of underfloor heating and 6 kilowatts of radiators, and I'm claiming an output from my heat pump of 12 kilowatts to match it at and if you notice, I haven't written a delta T on the heat pump because I didn't believe the delta T would remain at 5 if we maintain delta T5 at the underfloor and the radiators. And I've picked typical weather comp curves for these two systems. So I've gone with a 0.6 curve for the underfloor heating. I've got a spare finger to point to it. So and with a 1.4 curve for the radiators. So that would be a flow temperature at design outside temperature of -2, of 50 degrees flow at the radiator. Remember, that's delta T5, so that's a mean water temperature of 47.5. And I've deliberately gone for that. So it's the government are recommending a design temperature of 55. So it's under the government's designed specified temperature. And it's a very normal curve we find in existing radiators. And then I've gone for underfloor, and I've picked a system of underfloor that's been well installed. So it has a low curve of 0.6. I've done it deliberately to exaggerate the equation to prove a point. If the underfloor and the radiators were running at the same curve, then there would be no need for a blender. There wouldn't be a blender, and everything would be in balance. But for that, you would have to have the underfloor, in my opinion, running at a very poor efficiency. Right, so we've got no hydraulic separation, and we do the maths. Now, this was a bit challenging. I remembered at college that I learned how to do differential equations, simultaneous equations, and I was struggling to remember them, and my good wife, who has a degree in economics, not quite the same as science and engineering, couldn't remember the maths either, so I did a bit of YouTubing, and I found a Swedish method which seems a lot easier than the English method for simultaneous equations. I won't go through it because I'm going to make myself look too silly, but basically I went through it all and I found that my second flow rate on that system would have to be 3.57 litres per minute, and that my other flow rate coming back, so my main flow rate from the heat pump, would end up being 13.57 litres per minute, to mix the water to the correct flow temperature from our underfloor heating circuit. So then if we use a mass flow rate calculation or volumetric flow rate calculation, we can find out that for this system to have emitters running at delta T5, the heat pump would have a delta T of 11.7. So what would we do? Well, obviously the heat pump, we really need to be delta T5. So if we're going to put out 12 kilowatts and it's going to load match, there's no way for the underfloor to do anything. The blender is going to control its flow rate and its mixing there. And the temperature is fixed by the weather comp at the underfloor. So we're going to be squirting all of the extra water required through our radiator circuit. And you're going to get the associated noise with extremely high velocities through the radiators and an extremely low delta T. I haven't done the maths for this to work out what it is, but it wouldn't be too hard. We got a discrepancy of 3.57 litres, so we'd be squeezing another 3.57 litres per minute through our radiator system on top of everything else already at delta T5, and we know that it's not easy to get the flow rate of delta T5 through a radiator system. So it is my opinion that for this system to work, we would need to have some kind of hydraulic separation after the heat pump, as most manufacturers would recommend. And then our heat pump could run at its required delta T. Actually, I'm going to do a separate video on how it would work with a low loss header. So, but at the moment we can clearly see it won't work without one, and that there needs to be one to get the balance. The other thing I would argue is that if we use a low loss header to get the heat pump and the system in balance, our overall return temperature should be lower, and therefore delta T5 at the heat pump should be able to give us a lower output. So the output temperature of the heat pump would always be correct for the radiators, the flow would be correct, so there'd be no loss of efficiency from our heat pump if we were to use hydraulic separation. Now I've kind of ad-libbed that last bit. It sounds very logical in my brain as I sort of think it through, but again, give me some room on this. It's new and quite complicated. So my current thinking is we'd need hydraulic separation, but also we'd need to be able to control the flow rates. And this is my conundrum on heat pumps at the moment. We need some system that not just controls the heat pump, but that controls the flow rates and the balancing of the system, all as one system, like Wiesmann do more or less for their mixed systems with their boiler. Well, kind of. But what we need is a system whereby we can control the pumps after the buffer to make sure we keep the correct flow rates in the system at all times. And we need those flow rates to be variable as the flow rate from the heat pump varies. And as far as I know, that's not on the market at the moment, but we need it to be there. If you know different, if you know that system's available from a heat pump manufacturer, then I'd be interested to hear about it. But at the moment, I don't think it exists. And there's always going to be some sacrifices, and I'm not quite sure where the best place for those are. So sorry to be so undecisive. It's not normally the way I am, but I'm trying to think through several different concepts and new or reviving old mathematical knowledge all at the same time here. So anyway, I hope that's been more help than confusion. So yes, I hope that helps.